Okay, welcome back to the next session of K-5 Computer Science, integrating computer science throughout kindergarten through 5th grade in elementary school. This session is on communication and participation, computational communication in particular, and let's go ahead and get started. So this session focuses on practice 7 from the K-12 computer science frameworks that we've discussed before. And this practice is all about communicating about computing. So communication in its essence involves personal expression and exchanging ideas with others. So of course this relates to any subject, any grade level, any course, any elective, and in particular with computer science, the focus is on communicating with diverse audiences about computational artifacts. And remember, we're thinking about computational artifacts as projects that are made using computer science skills and knowledge. And then for students, the choices they make in the process to create them. The participation piece is more of a recent push in computer science and relates to how does this communication affect my interactions with other students and other participants, particularly in online communities, virtual communities, which is one of the main reasons why I've leveraged Scratch and that platform as a way to both showcase, create, and interact and communicate, and then participate with multiple users throughout that community. So when I'm talking about computational participation, I'm really referencing participation with other coders to create artifacts, and that can be students in the classroom, students in the school, students outside the school, a neighboring school. The sky's the limit. And then in a place where that is a safe place for students to thrive, learn, and create with each other. And Scratch is ideal for that. The participation piece, I talk about a little of that here because communication and being able to communicate computationally specific to computer science and the elements involved in that is key for being able to participate appropriately with other students, right? And as teachers, we're promoting communication skills every day in everything that we do, and creating this environment that is one where students thrive around learning and learn from each other and can, in this case and in general, create stuff together that is actually more complex and involves much more learning than they could otherwise and individually. So that's where computer science is now, that's where the world is now, that's where the workplace is, and as teachers, that's where we are as well. We work with our PLCs to improve our grade level, because if we were working alone, we would be isolated and wouldn't be pushed to learn new things. So that's the participation element. For communication, we're looking specifically at defining that as careful consideration of audiences. In the last session, I talked about ensuring that an attention to diversity and diverse audiences is a key element of the classroom environment that one sets, but also the cognitive elements for how students think. How does my experiences affect what I create, what I put together, what I program, the programs that I produce, and then how do others interact with those products. and then designing specific artifacts or projects or programs to specific audiences. So this is a key computer science, and these practices is well positioned as a tool to teach cultural diversity, empathy skills, respect, and how to interact with diverse audiences. So not only considering the audiences, but the choices that I make in the design, how does that interact with the audiences that will use it? And then second, ELA, teachers love this, using precise language in writing and speaking. Related to computer science, am I talking about inputs? Am I talking about programs? Am I talking about, in the case of Scratch, sprites? Am I talking about loops, conditionals, variables, remixing, those kinds of things? So helping kids to learn how to use the terminology. Teachers know this and promote vocabulary, but no longer are we just focusing on vocabulary. It's how kids are using that language and how they're interacting with others, how they're communicating, both verbally and in writing. And then also documenting that work over time. This is, as far as Scratch is concerned, this is easily done because students can save versions of their projects at various points, and then they can begin to see how their design process changes over time, where they started, where they were in the middle, where they ended, but not only that, reflecting on what that is like. So, I mean, even if this is a narrative of the day's work, verbally describing to the teacher what that work was like, what they did, and then which is I mean, that's a great assessment tool, right? So whenever teachers are asking questions, that's when you know how students are thinking about and grappling with the ideas that they're using in their design process and their understanding of it. So oftentimes observing classrooms or just listening to the environment, what's going on in the classroom, are the kids actually talking about the stuff that they're doing? And if they're not, are they talking about other ideas and subject matter that they're bringing into what they're working on in class? So teachers do this all the time. And then being able to express those ideas through many forms. I mentioned writing, word processing, PowerPoint presentations, Prezis. Scratch allows students to be able to provide feedback to each other, and it's interesting having that feedback as a component of the design process actually changes what is produced. And so that's something I'm going to show you today. The participation piece is the collaborating. How do I use this communication? How do I communicate? Now that I'm adept at being able to do this in the classroom, how do I take that to the next level so that I'm actually collaborating with others and designing with others to create really cool stuff that I couldn't have designed by myself? So sometimes projects, and there are many different virtual communities that does this. Yville is an example. Newgrounds, that's an adult community, but they're unfortunately that community is mainly males. But in all of these communities, it allows, if it's a good platform, it allows for projects to be modified and adapted over time by many users. So we see this in cloud computing and other applications. So the skills for communicating computationally, and then we'll embed some of the participation pieces, is being able to select, organize, and interpret data. Any subject that's being taught, any specials. This is a piece of that knowledge base, is being able to identify data, sort it, collect it, manipulate it, put it in forms that are understandable, and allow students to make inferences and conclusions from that data. And then being able to use that data source and that knowledge to come to conclusions and justify a particular position. So this is throughout standards in ELA, math, social studies, and science. And then describing, justifying, and documenting the processes that are involved in design and in the context of being able to produce solutions. What does that project and that design solve, and using that information to make goals around those solutions, towards those solutions. And then being able to articulate ideas responsibly, doing this in a way to where I'm not taking credit for someone else's work, giving other folks credit, and working as a team so that we're all part of this process, and whatever we produce is something that we all own. It's not something that I own because I was the one that was leading the charge. Everyone working with me is shared ownership there. So those are the three big areas that I'm talking about today, and what, as a teacher, what I want to shoot for. So let's talk about those areas. So number one, selecting, organizing, and interpreting the data. This is something that teachers do all the time. The cool thing about computer science is that this allows you, if gaining the skills and the coding skills, the ability to navigate some of these platforms and manipulate projects that are already available to you and programs that are already available, allows you to, as a teacher, promote this and teach this to another level. So being able to reference this data, being able to present it visually, and then using this data to support a claim. So I'm gonna just share my screen and show a few projects that I pulled up. So going on to the Scratch platform, just want to check in to make sure that everything is good to go. I don't see anyone saying they can't hear me. All right, so here we go. So going to, if again, you have a username on Scratch, you have you followed me, I've followed you, and you have access to all this information that I have on this profile. Going down, let's see, my stuff. I want to check out my stuff. So these were some of the projects that I've pulled together, and this is a studio. So this is where we've met a few times. Again, this could be a classroom for all of your students, and if you're departmentalized, you could have a science classroom. If you're not departmentalized, you've got all your students here. You could even have different sections for various subject levels. But we've talked about the ability of using this platform and using projects in Scratch that are portable. Something that students don't have to carry around. They don't have to carry around. I was in a school the other day, my habitat project, and lugged that around all day, which is a great project, by the way. But what if I did that project in this virtual community? I'm able to leverage 2 million projects and code related to that to build out a habitat project, and I could carry that to gym if I wanted to. So readily accessible at home and at school. That's the goal here. So there were a few, whenever I think of data, I typically think of math and science, but that's because my first love was science, and as a science teacher, we collected data all the time in our labs. But this also can mean gathering information and observations from whatever source to write a 5-paragraph essay or whatever the ELA teachers are doing, creative writing, or in social studies being able to make an argument for about something that's happening in history. But here, open this project up for a second. I like this one just because it's simple and kids can understand this. And when elementary school teachers look at their math standards in first grade and then show that to the third grade teachers, what you see through K5 in mathematics is making observations and collecting data. So that's a common theme throughout. So how tall is the hat? I often found that science teachers were, I'm going to say 3. Good try. Wasn't that great? It was actually 5. So when I had students coming into science all the time, they had trouble with this. The reason why was because in the grades before, they weren't actually, oh, I see, it's 5 now. They weren't actually making observations and collecting data and using, in this case, a ruler. How tall is the heart? 6. So this is just a way for students to practice. 6. Matching up objects to size. And then being able to take that to the next step. Let's see where we were. Being able to present this data visually and then using that data to support a claim. So when I'm thinking about using data and then presenting that visually, I'm thinking about Excel because it's a program that I'm very familiar with, and as teachers we use this quite a bit, and a great way to be able to present data. But in Scratch, there are many projects that actually incorporate similar types of skills. Let's see if I can find an example of this. Going back to my studio, here's a good example. All right, so this is a poll that's been created, and you saw this pop up. New Scratch account, changes to cloud data won't be saved yet, keep participating, and then that will be included. So this project actually, see how the complicated code here, how it was coded. But this project actually collects this data and then pulls it together with other people around the world who have participated in this project. So I see my daughter, who's 5 now, bringing home lots of math problems and different things that we work on together at home, but I see little or hear little evidence of her actually making observations, collecting data, and then collectively pooling that in a way to see trends, patterns, and make inferences from that. And she, like me, is a big picture person, likes to see what is the pattern here, what do I notice, what's the trend. So she looks for that kind of stuff, but she's not, I don't feel like she's getting that at school, and she's actually going to a really high achieving school. So like me, when I learned mathematics, or learning how to graph and collect data and all that good stuff, a lot of times it wasn't applied. But in this case, I like this. This is simple. So a teacher could introduce to the class, what's the favorite color? Students are all voting pink, and then I can see the results instantaneously. So then I see there's been 311 votes, and there actually, this is a pie chart or a pie visual of the data, so it's by percentage. but this actually shows the tally of it. And students can realize and see, the little ones can see that blue is by far the most favorite color of the folks that are participating. But if I wanted, as a teacher, I could remix this. I could download this. Let me go back. Where is my... You can see all the comments there, the communication that's happening on this project. I can add this to my studio. I've already done that right there. I can leave a comment. Click on the cloud data. I actually haven't even looked at this. So this is tabulating. First time I've seen this. It's tabulating all the votes that occurred and the data name and the user that collected it. Sometimes in elementary school, one sees a chart of students bringing in, collecting money, classes competing for some worthy cause. So go back to my daughter. She had saved over the course of 2 years $23 and decided she wanted to take that to her classroom and give that to feed sick people. So that was the charity, and then as a school and as a class, they were collecting that data and then representing that visually, which is one of the elements of this practice. So orange, see results, and there we go. And I'm trying to find I can remix it. And so I can't actually manipulate the cloud data. It pulls it off, and I'm able to manipulate this project and change it in a way, but yet it doesn't upload that to the cloud data. So in Excel, and I wanted to do this today, but to pull up how to create a pie chart and have it ready to go, students are actually determining. A good example of this would be the number of boys and girls, right? So that's a science concept. We know whenever humans are born, there's a 50-50 chance that the baby is going to have double X or XY and be male or female. Students may not necessarily know that coming in, right? So, but if they can collect data and actually chart this in a pie chart, they'll be able to see, more than likely in the room, there may be some, if it's a small classroom, it may be off, but then you could pair up with another classroom and then together begin to make those observations. And then over time, with enough of a sample size, the kids will begin to see that half the school or half the sample is boys, half are girls, and begin to make some inferences from that. What does that mean? So we see that. Is that the case outside the school? So some of those mathematical or scientific truisms, and students beginning to see that that's a thing, that's a trend, that's a pattern, and then justify using that data and that finding and the evidence around that finding to come to some type of conclusion. The same could be said for calculating pi. Not that that's something that first graders are doing all the time, but measuring the circumference to diameter, I believe, if I remember correctly, is going to give me 3.14, no matter what the size of the circle. So those are things that could be done in the classroom and in a way to where, students begin to make some conclusions. The same could be true for height, right? Height and age. So we know that students grow over time. At age 8, students have this height. At age 12, they have this height, and begin to see those patterns. So that's the goal there. I can make inferences from just numbers that I collect that don't make a lot of sense, but collectively begins to tell me something. All right. And then teaching the knowledge and skills to communicate the processes involved in the design and the solutions. What do I expect this to solve? What am I trying to solve? And this is around being able to describe, justify, and document what's happening in my design and in my product. So as students are working on a project, asking them questions around, why did you choose that particular color? Why did you choose that particular background? Does that take into account that you are trying to create something that's going to be for rural students in Alaska, or something of that nature? And then being able to use the precise language about the devices, the concepts, and the design. So am I talking about am I using an iPad? Am I using a touch screen? Am I using a mouse? Am I creating a program? Am I using sprites? Those kinds of things. And then the design process using that language in a way to where it communicates very specific ideas and then expresses those ideas. This is something that I think is happening more in K-5. My daughter came in, it's funny, yesterday actually, she came in and she said, if I get 50 points, I get to go to the principal's office and get a prize. I'm like, great. So 50 points for what, and why are you trying to get those points? And she wasn't able to describe that. All she knew was that she was 50 points away and she was just going to keep doing what she was doing to get that prize. So that, and especially today when you see PBIS in all schools, students are often more focused on the prize and what's needed to get there, and that rather than what does that do? What's the outcome of that? What does that solve? What am I trying to learn here? So being able to set goals and then having students communicate what do they expect. In designing programs in computer science, it could be that thinking about, for example, game design. What is my game? What is the purpose of the game? Who's going to use it? What does that look like? And then setting goals towards that particular outcome. So if it's movement, I'm needing to move sprite A to point X, Y, then what happens after that? And having students to be able to articulate that is related to cause and effect, and then being able to see the steps to get there. And then that's related to writing, that's related to problem solving, that's related to mathematical thinking, computational thinking, and then designing experiments in science, for example. And then documenting for the users who are going to use my project what it means. What is it? What's the purpose? How does it work? What do I need to do to manipulate it? What's the purpose of the game? What's my objective? What does it solve? Those kinds of things. And then giving and receiving feedback. That's for the input along the way, and also to take into the consideration diverse users for what the game, in this case, as an example, serves and who's it going to reach as far as output. So this piece, the give and the receive feedback, is really important on the computational participation piece. But if I can't talk about the choices I make in the design, why I designed it that way, if I can't use precise language about how to use it, what devices to use, how it's designed, and what principles are involved, and then if I can't document that in a way, if I can't communicate that in written form, video and verbal form, audio form, whatever form I'm using, whatever method of communication I'm using, then my ability to participate with others is going to be limited. And the feedback is important for being able to produce really, really good projects in the end. So you see this all the time in the gaming industry and social platforms like social media, like Facebook. Facebook will beta test some type of application. And so, and along the way, users are providing that feedback, and somehow I'm collecting that data on the Facebook end, and I'm processing that data, and then I'm making adjustments based on that. So the concept of big data is huge now, and even the little ones can start to use that. So let's think about how this is applied. Go back to my stuff. So this is a game that I was one of the judges in the National STEM Video Game Challenge, which has been launched it's been occurring every year since 2011, and I've been a judge for the last 3 years. And typically they task me with judging middle school games. So this was a particular game I judged. This was 2016, and this game actually won. So I went through and played the game and evaluated it using a rubric that they use to judge these games. But what I also did was I had my 2 nieces and my daughter, and then some of my cousins' kids at a family reunion of all places to play this game, and then I got their thoughts on what they thought about it. So what I want to highlight here is the using precise language, documenting how it works, how it functions, and then the giving and receiving feedback. So the feedback piece is what I want to hit here. You can see up here, there's a tutorial, references a tutorial, and describes how this works, gives some credit, and actually this game was posted. So the game was viewed 10,000 times. Middle schooler put this together. And the STEM Video Game Challenge considers middle school 4 through 6. So there were in our world, elementary schools and 4th graders and 5th graders that were involved. I'm not sure about this particular, so it may have been a 5th grader, but here you can see just the feedback that was provided. So being able to communicate something, a lot of these are just love it, likes in Facebook terms, although there is a like button up here somewhere. Notice this one, great game, but the health doesn't work. So 7 months ago. And that's some important feedback. This is really good feedback here. As a teacher, I want to set this up. I want to be able to use exemplars of great feedback and then feedback that is nice, like this. Awesome. That's great. That can definitely encourage a programmer to keep going and know that he or she is on the right track. But this feedback is very precise. It's communicated through, standard English. You can see there's periods, exclamation points, and commas and full sentences and all the good stuff. So this is really awesome. I found a bug though. Whenever you have the regeneration armor, you can keep clicking on the staircase and keep saying no, and you will regenerate health. So this particular bug that this person found, this user found, really informs the design of that, where the bugs are, and then how do I change it? What might I need to do? So if I'm designing this game and I posted it, I might interact with this user and ask some specifics. And then I may actually go on this feedback loop and ask for some suggestions on how to fix it. So you can see here, do a lot better if there were a lot less monsters. You should make it so you can drink the health potion. So cool idea, right? So keep on, shop isn't working. Then it says, never mind, it's all good. Music. I mean, clearly the folks that are commenting on this game have lots of opinion. If I'm the person who's actually creating this project, I'm going to go through this. I'm going to look for trends. I'm going to look for some things that stick out, some common pieces that all these users are stating, and that's going to give me some really good feedback. Now, as a teacher, we have, on a good day, 20 students, a K-5. On a really good day, maybe my class size is 15, but I may be approaching 21 or over, and then if I'm teaching a specials or an upper grade, then I've got lots of kids. So why not leverage this platform to actually provide some feedback or create your own studio? That way you can control who is able to participate computationally and communicate with my students. As a grade level, do this across grade levels. One of the things that we did in the work that I did around game design was the kids created games, and we created an environment, and we're very intentional on creating an environment that communicated precise language, that was supportive and provided feedback in a way that was helpful, informative, and considerate. And then we opened that up for other users in the school, so the school community, to come in and provide feedback. We had these little note cards. And then in another session, we had this feedback running, the threads running on the comment section to be able to provide that information. And once that happened, what we found was that students took off very quickly in their design, and they learned a lot more computer science in the process. And then they got some really good ideas for being able to integrate the other subject matter in the process. So leverage your community, leverage your classroom, so that it's not just you standing out there alone providing that feedback. We can't do it all. But I do not know how many comments were shared, but this was one that just really took off. There's a reason why this project was first place in the country on the National STEM Video Game Challenge. People were enthralled with it. Students were enthralled with it. There was something about this project. And that's important for assessment too, right? I'm trying to assess this. I'm trying to assess the usability or interest of users in using this project, having the students post, and controlling where the post is, and seeing how other people collectively gravitate towards that project. And post is, that's a good measure. That's a good measure of interest by end users. That teachers, I'm in my 40s. I don't know how cool this project is relative to other fourth graders. So I'm going to use and leverage this community to help me get there and to assess that if I am assessing that. So use the community. And then being able to articulate ideas responsibly. I can't tell you how many times, and this is a common problem that we have, especially in today's world, where students are able to pull down and copy and paste, and they're writing samples out there, there are essays, there all this stuff out there that students can own and claim for themselves. And giving them zeros or punishing them is not going to get them where they need to be. But instilling in them a type of respect and understanding that that's not my idea, and that's not my project, and that's not my code, that's not my writing sample, that's not my presentation, is where it starts. That's where the solution lies. But I can understand that I can use that as long as I am able to attribute the ownership to someone else, thank them, and share that give them credit for it, right? So a good way to showcase this and to discuss this and actually do this in practice with students in the classroom is to start with a project that the students made, or give implement different types of projects and have students start with that, and then allow other students to download that project, to include it in their site if they have their own studio, and then they remix it. Cool thing about Scratch is that, let me find this again, sorry. I think, oh, this is the one I found. I found this earlier today. 3D Thing, version 2 remix. I chose this project because the intention of this project was to have others remix it. And the code changed over time. I can remix this by now. I saved it, you notice there, and I can play with it and change. We've talked about that before. But what I love about Scratch is I can view the remix tree. Come on. Yeah, I looked at it earlier. Let's see. Actually, I think because I saved it, I wasn't able to see it being remixed. But here, this shows when the project was implemented. It's implemented, and then the branches of this over time. So you can see that there are links to different remixes at every point. And so the credit is given instantaneously by Scratch, and links all of these. Let me go back over here. You can see that I can click on there, and voila, I'm at a different version of this. Thanks to Source Apple is cute. Sour Apple is cute. 3D Circle Thing project remix, and then this is the thanks to the original project. So Scratch is a great platform to be able to model that that credit. Very important. Trust me. High school teachers will thank you, and middle school teachers will thank you immensely being able to, starting here with this and really getting students to appreciate the work of others and give them credit. So that is our session for today. The links to being able to see more on the remixing, credit, feedback, talking about choices in the data are all there, and these projects are in the studio website. And we will see you next time.